Hello everyone, welcome to Engineer's Edge. So in this video I'll be speaking about computer networks unit 1 TCP/IP protocol suite. So TCP/IP, before speaking about TCP/IP protocol suite, you need to know what is the full form of TCP and what is IP. So TCP stands for Transmission Control Protocol and IP stands for Internet Protocol. So wait, before knowing about TCP/IP, let us know what is a protocol. So a protocol is defines a set of standard rules and procedures where a sender and receiver have to follow those set of rules and regulations. Not only the sender and receiver, also the intermediary devices which are present between the sender and receiver. Even those devices have to follow set of rules and regulations in order to perform effective communication, and it is a hierarchical protocol. So basically TCP/IP is a hierarchical protocol which is made up of interactive modules. So what the moment I tell the word hierarchy, you should be able to understand what is the meaning of that. So hierarchical protocol means the higher layer protocols are supported by the services which are provided by the lower layer protocols. So before knowing the TCP/IP layers, TCP layers, let us know the layers which are present in the OSI model. So OSI stands for Open System Interconnection. So OSI model consists of 7 layers. So that is physical layer, data link layer, network, transport, session, presentation, and application layer. So the difference between OSI model and the current TCP/IP model is session and presentation layer. These two are merged and are kept in application layer. So that is the change, and these are the original layers and this is the currently used layers. Now let us consider the understanding this diagram. So how does the communication is going to happen between the two devices? So for example, it is a computer, and here this X which is marked, it is the router, and this B and C are the computers. So this router enables to or helps to perform communication between A and B. When we are sending the message between any two computers, the messages is sent in the form of packets. So router, what is going to happen? Router, it is going to maintain the routing table. So routing table in the sense it will maintain all the shortest distances. Like in order, suppose if a computer named A sends one of the packet to router 1, then from router 1 it will measure to which router the data should be sent in order to have minimum number of hops. So that is the purpose of router. And link 1, link 2, link 3 is nothing but we are kept in order to establish the link. That's it. Now communication, how does the communication happens? So here the message comes from like to the application layer, then from application goes to transport, from transport to network, from network to data link, and then to physical, and then it comes to the switch will be applicable only for physical and data link layer, and the router will be applicable for the bottom tier, that is physical, data link, and network layer. So here the host A needs to create a message in the application layer and send it down such that it is physically sent to the dictionary. Now layers in the TCP/IP protocol suite. So for better understanding of functionalities of each layer, we need to think about the logical connections. So the logical connections, these dotted lines, what we are able to see. So these dotted lines in the figure, it is used to represent the logical connection. And now it can be seen that the duties of application, transport, and network layer, it is end to end, whereas physical and data link layer are hop to hop in a host or router. Now the domain of top three layers in the sense application, transport, and network layer. These three layers will come to internet. And now the bottom two layers is the link. Now data unit or packet should not be changed at both switch and router in the top three layers. And the packet can be changed at the bottom layers or only at the routers. Now with this you would have got a clear understanding about the computer networks. So now let us start learning the description, like what is the purpose of each and every layer which is used in TCP/IP. So let's go from bottom to top. So the first layer comes with the physical layer, as you have already seen in the diagram here. So physical is the bottommost. Okay, so what the purpose of physical layer? It is used to it is responsible for carrying the individual bits in frame across the link. Now, two devices, for example, take PCA and PCB. like personal computer named A and B. So these two computers are connected either by air or wired medium. So when it is connected by air medium, the signals are sent in the form of optical signals. But if they are wired, they are sent in the form of electrical signals. Okay. So now the purpose, let us come to the data link layer. So in data link layer, we are going to deal with the routers and how each and every computer are connected to each other. There are many types of networks which are there like LAN, WAN, MAN, etc. So the router, as I already said, the purpose of router is to maintain a routing table and also have the shortest path or get the shortest path, means choosing the best link in order to transmit the packet. So here the responsibilities of data link layer are it works at hop to hop level, and data link layer is sufficient to communicate between two nodes within a specific network. And now data link layer and network and transport layer, especially these two layers, I repeat, data link layer and transport layer, these two layers are responsible for error control, flow control, and congestion control. So what do you mean by error control, flow control, and congestion control? I'll be telling in the upcoming videos. So as of now, let us know just the protocols which are used in error control, flow control, and congestion control. So coming to the flow control, the protocols use the stop and wait. Coming to the error control, we are having methods, that is cyclic redundancy check, checksum, and parity bit checking. So error control means early detection of errors. So before sending the packet itself, are there any errors or not? Access control means improves the accessibility of the network. So protocols which are used is CSMA CD, CSMA CA. CSMA is very very important even from gate exam point of view and also from the engineering point of view. So framing, so data packets. So packet, as we all know, it consists of header and trail and payload. So each packet is divided into fixed size frames, which increases the reliability. Now network layer. So network layer is responsible for delivering a packet. Now here network layer, it uses IP. So routers in the path, those routers which are present, I already said those are responsible for choosing the best path in order to reach the destination. So responsible for routing is forwarding the packet at each router. So IP is a connectionless protocol. So it provides no flow control, no error control, and no condition control. So the protocols which are coming under network layer are ICMP, IGMP, DHCP, and ARP. Coming for the transport layer, here also it is responsible for end-to-end communication. Segmentation is done here to get the message or packet in the form of segments. So first, the moment when I tell the word segment, we have to know the name of the message which is given for each layer. So when we are performing the transmission between the two devices, there is a name, the separate name for each message from one layer to another layer. For example, when I consider here in the application layer, the message which are going to be sent, the message is going to be named as message itself, but in transport layer it is considered as segment or user datagram. For network layer it is considered as datagram. For data link layer it is considered as frame. For physical layer it is considered as stream of bits. Now, so segmentation is done here in order to get the message of packet. As I said, in transport layer, the message will be called as segment or also called as user datagram. Now, since the segment through the logical connection, so the layers which will come under this layer are TCP and UDP. TCP stands for Transmission Control Protocol, UDP stands for User Datagram Protocol. So the difference between transmission control protocol and user datagram protocol are, so transmission control protocol is basically a connection oriented protocol, but UDP is connectionless oriented protocol. So since it is connection oriented protocol, TCP is slow but UDP is fast. But since it is fast, it doesn't mean that UDP is reliable. TCP is reliable, UDP is not reliable one. Now application layer. Coming to the application layer, so application layer, the communication is done between two processes. So there are many layers which are used in this, many protocols which are used in this layer. So HTTP, SMTP, FTP, Telnet, SNMP, DNS, and IGMP. So this video was just in order to give an introduction about the networks. So in the upcoming videos, I will be continuing with the topics of encapsulation, decapsulation. Thank you. Please share this video with your friends in order to understand the about computer networks.